Okay, so this exercise 3, in this you have this network. So consider the following network for conducting a 2-week 10 working days computer training class. And we have this network. Construct a schedule showing early starts for all activities, late starts for all activities, slack for all activities, critical path, and then there is part B as well. But let's do this part A first. So actually this activity on arrow network has been shown, but you may be more familiar, more comfortable doing it in activity on node network. So we can simply do it on activity on node network. So we can see that this network is starting from activities A and C. So yeah, so activities A and C, A and C. So I draw these two activities in the form of nodes. Then B, because B is preceded by A, and D is preceded by C. So D is preceded by C, and both actually start at the same time. This is the start. Okay, and then E is preceded by both B and D. So it's a very simple network. E is preceded by both B and D. That's it. And then this is the finish. So the durations are 7, 6, 3, 3. This is 3. Let's erase it. 3 and 2. Okay. So now we can perform the forward and backward pass. So we can start from 0, 0, 7, 0, 6, 7, 10, and 6, 9. So it will be 10, 12. Then it is 12, 10, 10, 7. Here it will be 7, 1, and it will be 10 and 7, 7, 0, 0. So you can see that the numbers which I have just put are like the early starts. So early starts of A is 0, early start of B is 7, and like that. And similarly, you also know the late starts as well. So early starts and late starts. So we have already provided the answers for this. And the slacks. So the slacks are 1 and 1 over here. Slacks are 1 and so 1 is slack here, 1 slack is here. Because slack is the difference between the late start and early start, or late finish and early finish. For these activities A, B, and E, there is a 0 slack. And the critical path will be, all these, for example, all these activities with 0 slack, that those will show the critical path. So the critical path is A, B, and E. Okay, so after the critical path, now we can move to the part B. So given the following, so the same project, but now we have been given the cost data. So for example, activity A, B, C, D, E, and then their small description has been given. So the crash time, crash cost, normal time, normal cost has been given. And we know the total of the crash cost is 3,100, and the total of the normal cost we can also calculate. But let's see what is the question. It says find the crash cost per day. Crash cost per day. Well, actually it is for each activity. So crash cost per day. So for example, for activity A, it will be 800 minus 500 divided by 7 minus 4. So you can represent it by negative or positive, but it doesn't matter. So anyway, crash cost is like cost increase per and per day decrease, okay, of the duration. So it will be 300 divided by 3, it will be $100. Okay, so well, you see 800 minus 500 divided by 7 minus 4. Okay, 7 minus 4. So it is then calculated $100 per day. Okay, per day. So similarly, we can calculate for other as well. So this will be 150 divided by 1, so $150 per day. And this will be 4 divided by 2, 200 per day. And this will be 150 again. And this will be 250. Okay, so these are the crash cost per day for each activity. Okay, here you can see that next question. Which activities should be crashed to meet a project deadline of 10 days with the minimum cost? Assume partial crashing. Okay, so partial crashing means we can crash for 1 day. So 1 day, 2 day, 3 day within the limits of the activities. So we need to meet a deadline of 10 days. So originally the project was 12 days, as we can see here. 12 days duration. 12 days duration. Okay, and then there are two parts, ABE and CDE. ABE and CDE. So there are two paths. So one path is ABE, the other path is CDE. CDE. So ABE is 12. So you can see that this is the here normal duration. If you see this normal duration, so AB 7 plus 3 9 plus 2 is 12. 7 plus 3 is 10 plus 2 is 12. And CDE 6 plus 3 9 plus 2 is 11. 6 plus 3, yeah, it's 11. 6 plus 3 is 9 plus 2 is 11. Okay, so we have to complete the project in 10 days. So how can we do that? So in this case, we have to look at the critical path ABE, and on this critical path, if you see that activity A has 100 days of crash cost, B has 150 days, and E has 250 days. So the cheapest of the activity to crash is activity A. So we can crash, first of all, we can crash that activity for 1 day. So A decrease it by 1 day. So then this path will become 11 days long because A has decreased by 1 day, and CDE will remain as same. So this is at the cost of $100. Okay, plus $100, which is the crash cost of activity. But now in this situation, here from 11 days, if we have to move to 10 days, then we need to further reduce it by 1 day. So this is now possible by considering both paths. Okay, so if you take A, if you decrease from in path ABE, A is the cheapest activity. In CDE, which one is the cheapest? In CDE, the cheapest is 200 and D is 150. D is 150 from here. So if I choose activity A from here and D as 150 from here, so the total of that will be 100 plus 150, it will be 250. There is another possibility. If because we can see that activity E is a common activity, so if I choose activity E over here and the reduce activity E by 1 day, so the cost increase will be 250. So which is the same. So we can adopt any of these two options over here. So maybe I can choose activity E to decrease by 1 day over here. So this will become 10 and this will become 10, but that will be with the cost increase of $250. So a total cost increase will be, so which activities should be crashed to meet a project deadline of 10 days with the minimum cost? So our choice is A by 1 day and E by 1 day. And the other choice which I just mentioned was that A by 1 day first and then 1 day again. So A by 2 days and then D by 1 day. So in both situations, the cost will be $350. The total cost will be $350. So the question 3 is find the new cost. So the new cost is actually the original cost plus $350. So original cost was 507, 1,200, 1,400, 1,700, and then plus 350. So it will be the new cost is then $2,050. Let me check again. It is 7, 1, 12, 14, 17, and then 2020, $2,050. And is partial crashing an appropriate assumption in this kind of project? Yeah. Looking at the choice of the description of the activities, maybe some of the activities should not be reduced. So for example, a schedule class, if the schedule class means that it is a class which is to be taken for 2 days, so reducing the duration of this from 2 days to 1 day may not be an appropriate choice. So in that situation, you may not consider reducing activity E. Then you may consider reducing activity A by 2 day and activity D by 1 day. But because since in this case both options will incur an extra cost of $350. So the answer for this question depends on the what type of activities are we considering and whether those activities are appropriate to be crashed. So we need to look at the description of the